Move away from a fire, and it cools down. That's the rule. Somehow, the sun's outer atmosphere breaks it completely. The sun's surface runs about 5,500 degrees Celsius. Just above it, within thousands of kilometers, the outer atmosphere somehow cranks past 1,000,000 degrees. Distance was supposed to help. Nobody knows for certain why, and figuring it out means walking through every layer of the sun, from the fusion furnace buried at its center to the invisible edge where its influence finally runs out. Here's the plan. Core to corona, hottest to somehow hotter, until we find the layer that isn't supposed to exist. Layer 1, the core. Fusion furnace, dead center, crushed under the weight of the entire star. Down here, pressure and heat get so violent that hydrogen nuclei get shoved together until they fuse into helium. This is not a metaphor. This is a bomb, permanently, on purpose. Roughly 15 million degrees Celsius. With pressure so extreme the core is packed roughly 14 times denser than lead here on Earth. Basically, the center of the sun is nature's way of saying, what if we made a bomb? But permanently, on purpose, for billions of years. Every second, the core turns a staggering amount of hydrogen into helium and releases pure energy as gamma-ray light. That light has nowhere fast to go. Layer 2, the radiative zone. Picture a photon trying to walk in a straight line through a crowd so packed it can't move. It gets absorbed and re-emitted, over and over, bouncing in random directions through plasma so dense that light itself gets stuck. A single photon born in the core can take over 100,000 years to randomly stumble its way out of this layer alone. That photon lighting your face right now left the sun's core before humans had invented agriculture. It's just been stuck in traffic, and that's just to cross one layer. The sun isn't done making this photon's life difficult. Layer 3, the convective zone, where the sun stops transporting heat with light and starts doing it the way boiling water does. Hot plasma rises, cools near the top, sinks back down, and drags the sun's heat outward in slow, churning currents the size of countries. You can actually see the tops of these currents. They're called granules, and each one boils for about 20 minutes before it sinks and reforms. This churning also generates the sun's magnetic field, the same magnetic field that, stick with me, becomes the answer to everything later in this video. For now, just remember, convection equals magnetism. That detail is about to matter more than you think. Layer 4, the photosphere. This is the surface of the sun, the layer that actually emits the sunlight you're using to read this sentence. The photosphere reads as the sun's edge. From here you'd bet everything keeps cooling as you back away. The sun is about to take that bet and win. Layer 5, the chromosphere. This is where farther out equals colder, quietly checks out, and stops showing up to work. The photosphere looks like the natural edge of the sun. From here, you'd expect things to just keep cooling as you move away. They don't. Layer 5, the chromosphere. And this is where the rule everyone would guess, farther from the surface, colder, starts quietly falling apart. Just above the photosphere, temperature should keep dropping. Instead it climbs back up to roughly 20,000 degrees Celsius. This is also where towering arcs of plasma called prominences erupt, some large enough to swallow several Earths stacked end to end. Already stranger. But the chromosphere's temperature spike is nothing compared to what's waiting one layer further out. Layer 6, the corona, the outermost atmosphere of the sun, and the layer that broke the rule you learned back in scene 1. Closer to the surface equals hotter, obviously. The corona, far from the surface, is over 100 times hotter. The corona routinely reaches 1 to 3 million degrees Celsius. That's not a typo. That's hundreds of times hotter than the surface directly beneath it. It's like standing 3 feet from a campfire and being fine, then walking 20 feet away and spontaneously combusting. Layer 6, the corona, the sun's outermost atmosphere, and the one layer that flat out breaks the rule from scene 1. So where's the extra energy coming from? Remember the magnetic field the convective zone was busy generating? Here's where it comes back. The corona hits 1 to 3 million degrees Celsius. Not a typo. That's hundreds of times hotter than the surface sitting right underneath it. Neither is fully confirmed. Both are still active research. But both agree on the same underlying answer. The magnetic field born down in the convective zone is what's cooking the corona from the outside in. So here's the pattern once you connect it. It was never really about distance from the core at all. Every layer that got hotter than expected got there through the sun's magnetic field, not its fire. Fusion just lit the furnace. Magnetism decided where the heat actually goes. And the corona is so hot and so wildly magnetized that gravity can no longer hold on to it. it starts to escape. Layer 7, if you can call it a layer, the solar wind. A constant stream of charged particles blasting outward from the corona in every direction. Fusion just lit the furnace. Magnetism grabbed the wheel and decided where every bit of that heat actually goes. The corona gets so hot and so magnetically wound up that gravity loses its grip. The sun starts leaking into space. Layer 7, loosely speaking, the solar wind. A non-stop blast of charged particles firing outward from the corona in every direction at once. It took a spacecraft launched in 1977 35 years just to reach the edge of the sun's exhale. Space is rude like that. Eventually, it slams into the thin gas drifting between stars, the interstellar medium. Wherever the two pressures fight to a draw, that's the heliopause, which finally answers the question from the start. The corona is hotter than the surface because the sun never stopped being a magnet. And that magnet is what builds the bubble every planet here lives inside. That bubble, called the heliosphere, deflects a huge share of the high-energy particles drifting in from the rest of the galaxy. In a very real sense, you're standing inside the sun's atmosphere right now, and it's protecting you. So next time someone tells you the sun is just a ball of fire, you now know it's closer to a fusion furnace, wrapped in a boiling ocean, wearing an atmosphere that breaks physics, blowing a magnetic bubble around your entire solar system. Subscribe for the next one. What actually happens when that magnetic bubble misfires and a solar storm heads straight for Earth?